Hey students, welcome back. Here we will finish up this video we started on the laws of exponents, and this is the sixth law of exponent, where we shall be talking about fractional exponents. By now I expect that you should have viewed the first and second videos on exponents. Alright, here fractional exponents, this is kind of tricky and you've got to pay attention very well. You know, when you have the exponent now as a fraction or a negative fractional exponent, that's the next thing we'll talk about, because here we will just talk about positive fractional exponents. If we have something like x raised to power 1 over 2, now when we have something like x raised to power 2, we know that it's x times x. That is easy because the exponent is an integer exponent. Alright, it tells us how many times to multiply the base. But it becomes tricky when we have a fractional exponent. So when we have x raised to power 1 over 2, this means just the square root of x. That is what it means. That is what it means. Of course, in your calculator, you see it this way. Sometimes you see the square root of x, and also you see the cube. Some people, you see this, you also see this cube root of x. And some people just don't see anything like this. Some people just see it like this. And sometimes you see x root of y, x root of y. Or some people will see it as y root of x, y root of x. Yeah. Or some people won't see anything here. I mean, it all depends on the way it is in your calculator. It all says the same thing. Alright, so if we have x raised to power 1 over 2, it means the square root of x. If we have x raised to power 1 over 3, it means the cube root of x, cube root. If we have x raised to power 1 over 4, it means the fourth root of x. If we have x raised to power 1 over 5, it means the fifth root of x. Fifth root, sixth root, seventh root, eighth root, ninth root, 10th root, 11th root. So the same way, the same thing is what it means. Let me tell you something interesting. If you have 4 raised to power 1 over 2, right? So that means what? Square root of 4. Square root of 4. And of course, square root of 4, you will know it immediately, even without looking at your calculator. You know it's 2. Okay, but how do we know this? Let me tell you why we say that the x raised to power half should be the square root. I'm going to prove it to you now. And why x raised to power 1 over 3 should be the cube root, and the rest of them. Now this 4, you also know that 4 raised to power 1 over 2 means 2 raised to power 2, then 1 over 2. That is what it means again. Okay, 2 raised to power 2, then raised to power 1 over 2. And from the power rule, we see that this is 2 raised to power 2 times 1 over 2. And of course, 2 will cross out 2, and you have 2 raised to power 1, which is 2. So, this same 2 is the square root of 4, which is 2. The same thing goes with 27. Cube root of 27. If you do that, it gives you what? 3. But how? How? We see that cube root of 27, you can say that this is also 27 raised to power 1 over 3. That is what it means. Even if I didn't put the parentheses there, it's okay. I can still write it this way, 27 raised to power 1 over 3. That is what cube root of 27 means. Now, this is vice versa. If x raised to power 1 over 2 is square root of x, that means that square root of x is also equal to x raised to power half, x to the 1/2 power. So this means what? 3 raised to power 3, all raised to power 1 over 3. And this will be 3 times 1 over 3, and that will be 3. Cube root of 27. So that is the way fractional exponent goes. Right? Now, what if we have x raised to power 2 over 3? will now give the cube root. Remember, this is like 2 times 1 over 3, which is 2 over 3. This means the cube root of x all raised to power 2. That is what it means. Or you can have it like this. Cube root of x squared. It is still the same thing. Now, depending on the question you're given, you might either choose to do it this way or this way. If we have x raised to power 4 over 5, this means the 5th root of x, all raised to power 4. Or you can have it as the 5th root of x 4. Sometimes you might want to raise x to the 4th power first before you take the 5th root. Okay, it all depends on the question that you are given. Let's look at an example. Assuming we have a 16 over 36 raised to power 1 over 2. This is pretty much easy, okay? Because this is just square root of 16 over 36. Of course, you know, it's of no use doing 16 divided by 36 first, which will now give you a decimal, and then you do the square root. No. All you can do is just to do square root of 16 over square root of 36. And that simply gives you 4 over 6, which is 2 over 3. Or, you can also do it this way. That this is 16 raised to power 1/2 over 36 raised to power 1/2, which is now square root of 16 over square root of 36, which is now 4 over 6, which is 2 over 3. Whichever one. Another one. What if you have this? 64 over 125, all raised to power 2 over 3. What if you have this now? So let me now tell you which way to, write it out in the 2 ways you can have it, and then you decide which way is better. You can either write it this way: cube root of 64 over 125, all raised to power 2, or cube root of 64 over 125, then all squared here. Okay, come on. You'd want to try to avoid dealing with big numbers, because when you come and square this, and you square this, and then you now take the cube root, come on, you're playing with big numbers. You want to make things as simple as possible. So I will go with this. This is what I will go with. I'll choose this. Because first of all, find the cube root of 64 over 125. It gives me 4 over 5. And then I square this, it gives me 4 squared over 5 squared. And that is 16 over 25. That is it. But you can still do this and still get the same answer. Right? But what you want to avoid is, first of all, dividing 64 divided by 125, which will now give you a decimal, and then squaring it, and then finding the cube root. You know, and with the approximation errors, you might not get exactly the same thing. When they give you something like this, they want, most 95% of the time, they want you to leave it as a fraction rather than a decimal. All right, now let's do a negative fractional exponent, and I think that should be the last one. Negative fractional exponent. It still works the same way as the negative exponent. That's the same thing. If we have x raised to power negative 1 over 2, this means 1 over x raised to power 1 over 2, which is 1 over square root of x, is still the same thing. So let's say we have this 64 over 125 raised to power negative 2 over 3. Right? Of course, if you look at this, the answer will be 25 over 16. But probably you still want me to solve it. So I'm going to solve it. Now this is 1 over 64 over 125 raised to power 2 over 3. And that will give you 1 over cube root of 64 over 125 all squared. Which will now be 1 over 4 over 5 all squared. Which is 1 over 4 squared over 5 squared. Or you can do 1 divided by, 1 divided by 4 squared over 5 squared. Which is 1 times 5 squared over 4 squared. Which is 25 over 16. Or you can do it. Alright? There are so many questions on this that I probably wouldn't do, but if you the main thing is to understand the principle. Once you get the principle, it's easy. So please make your comments or holler at me if you have any question on this. Okay? Just make the comment or ask me a question when you see me in class. Thank you so much and have a great day.